In southern Italy, on the shores of the Gulf of Naples, lies a region that seems ordinary but holds extraordinary geological potential. Beneath this area is Campi Flegrei, a volcanic caldera about 12 kilometers in diameter. Unlike other cone-shaped volcanoes, Campi Flegrei is a vast basin covered by cities, infrastructure, and human activity. About 500,000 people live above this system. This makes it one of the most densely populated volcanic areas in the world. In recent decades, scientists have observed significant changes in the soil conditions in this region, particularly in Pozzuoli. A phenomenon known as Bradyseism has caused the land surface to gradually rise since the 1950s, with a total uplift approaching 4 meters. Of particular concern is not only the magnitude of these changes, but also their acceleration in recent years. This deformation indicates a steadily increasing pressure beneath the surface. Geophysically, this is related to the dynamics of magma and volcanic gases at depths of several kilometers. As hot fluids and gases accumulate in the underground chamber, pressure increases on the overlying rock layers. As a result, the ground surface rises and small cracks begin to form. This process also opens pathways for gas to escape to the surface, providing important clues about activity within the volcanic system. Another indication supporting this analysis comes from the Solfatara crater, one of Campi Flegrei's fumarole centers. Since 2015, gas composition has changed significantly with increased carbon dioxide and other magmatic gases. Ground temperatures have also risen in this area. These data suggest the subsurface heat source is more active and now affects surface conditions. Seismic activity is also an important indicator. In May 2024, the Campi Flegrei region experienced its largest earthquake in 4 decades. Although moderate in magnitude, this event is significant in the context of volcanology. The earthquake reflects the rock's response to increasing internal pressure and confirms that the system is in a dynamic phase. To understand potential future developments, researchers use various modeling approaches. One method used is the finite time singularity model, which helps predict when a system might reach a critical state. The analysis suggests the potential period between 2030 and 2034 as a phase where pressure could reach its maximum. While an eruption cannot be confirmed, these findings indicate an increased risk that warrants vigilance. Geological records indicate that Campi Flegrei has a history of major eruptions. Approximately 39,000 years ago, a massive eruption known as the Campanian Ignimbrite occurred. This event released large amounts of volcanic material into the atmosphere and had widespread environmental impacts. Some studies have even linked its impact to the decline of the Neanderthal population in Europe, although this relationship remains a matter of scientific study. Currently, the greatest challenge lies in the high population density surrounding the Naples area. Modern infrastructure and intense economic activity make potential impacts far more complex than in the past. In certain situations, mitigation efforts such as mass evacuations will face significant challenges, both logistical and time-consuming. Italian authorities, along with the scientific community, continue to closely monitor developments at Campi Flegrei. Internal discussions regarding mitigation measures and emergency scenarios have also taken place, although not all of them have been made public. This reflects a heightened level of awareness of ongoing changes. Overall, Campi Flegrei exhibits the characteristics of an active, evolving volcanic system. The combination of ground deformation, changes in gas emissions, and seismic activity is an important indicator in understanding subsurface conditions. While the timing of an eruption remains uncertain, available data suggests that the system is moving into a more critical phase. In this context, continuous monitoring and preparedness are key. Because beneath the seemingly stable surface, geological processes are ongoing, and if current trends continue, the countdown to a decisive phase has likely begun.